Hello everyone. In the previous videos, so far we have built a delta system that keeps movement consistent across the frame rates, and we added easing functions that can make the motion feel natural and weighted, and we used the Lerp method to make a cursor move smoothly from and to follow the mouse. But here's what all the three had in common. The movement is always had a destination, a fixed endpoint, and was traveling towards something. But actual real world physics does not have an actual goal, like an actual destination. When you drop a ball on the ground, under gravity will take over. It accelerates on the way down and slams into the floor and bounces back up. It will lose nothing and will go forever. The ball doesn't know where it's going. It only knows its current velocity and forces acting on it right at the present time. So that is exactly how real physics engines work. Like in games, for example, I am not much of a gamer, but I have seen in some football games and some cricket emulator games and things like that. It will run the exact loop again and again, like gravity, velocity, collision, and it will repeats again. Today, that is what we are going to build that loop for by ourselves. And yeah, welcome to Scratch Start. And today we are going to build a continuous loop, bounce loop. Now let's start writing the main JavaScript program. And I have written the HTML and CSS stylings as always. Let's start directly with the JavaScript. Initially, as always, we have to create variables using the identifiers. So I'm creating a variable called ball using a query selector. And the class is ball. Next, I am creating another element called the scene. I am selecting it by document query selector again. Query selector, and the class is scene. Next, I am going to create three different set of values. To build an environment with physics, we first need to define its mathematical reality. So for that, I am initially creating two variables called x and y. X and y. What these x and y represent is the position x, the spatial coordinates, the position of the ball coordinates in x and y axis. 100 and giving it 50. And next I am giving the directional velocities. Yes, velocity in x direction, and velocity in y direction. I am giving initial values as 5 and 0. And next I am assigning the gravity value. In real world, gravity exists in physics, right? Then gravity equal to, I am giving value as 0.25. So now we have to write the main brain of the logic, that is animate function. Inside this we have to write the main logics, all the logics here. So initially I am going to declare the width, the maximum width and the height of the container of the scene. So we have done this already in a previous task 2. Max x equal to scene's width, that is in x direction it is width, scene dot client width minus balls client width. Balls client width. And another is max y, that is in another vertical direction. Scene dot client height here, client height, and for ball the client height here again, for client height. And next is the gravity. We have assigned the gravity as 0.25, but during each movement the gravity will increase. That means let's go to the browser. As you can see here, when initially the ball is here, if it comes downwards, the gravity actually increases. Gravity is keep pulling the ball downwards, so the gravity is increasing. So we have to increase the gravity exponentially. So for that I am writing another formula here, mathematical expression for gravity. It is moving on, the ball is bouncing in the y direction, so selecting velocity y and adding it with the gravity, and that's all. Now we have to move the ball. So to move the balls, we have to change the x coordinates and the y coordinates. So to change the x coordinate, I'm changing the velocity in x direction, adding with the initial thing. That means what actually happens here is velocity y x new is equal to velocity y plus gravity y. That's all. What is here happening. It is in x direction, so I am writing in x direction. What is said is a y direction, so that is what we are going to write now. In y direction, velocity y, that's all. We have to add the initial values with the velocity y, that's all. Now we have to write the logic for 4 collisions. For the 4 collisions, I am using if logic, if statement here. If the y coordinate is greater than or equal to max y, that means we have to assign y equal to max y, and we have to change the velocity to update the velocity in y direction, velocity in y direction multiplied with the minus 1. That's all. Now it is for the floor collisions. That means here the browser, whenever the ball bounces, logic for the ball to bounce here in the floor, it is the ceiling and it is a left wall and the right wall. So bottom portion is finished. Now we have to write for the ceiling portion, that is the top portion. For the ceiling collision, the same logic here. It is also in y direction, but we are not going to take the maximum width of the scene. Here we are going to consider only the coordinates here. So y is less than or equal to 0. We have to assign y equal to 0 and velocity y multiplied with minus 1. Next, for the 2 walls now. Now initially I will write for the right wall collision. We have to use the same logic but with the x coordinates, that's all. If x is greater than or equal to max x, then we have to declare x is equal to max x, and write the same velocity x equal to multiply with minus 1, velocity x star minus 1. And that's all. Now in the leftward, for the leftward collision, we have to write the same. If x coordinate is less than or equal to 0, we have to consider x, assign x as 0, and calculate the velocity x star minus 1. That's all. Now we have to transform the ball. The collision will happen according to this logic. After collision, we have to transform the ball in different places, right? So selecting the ball, using style, I'm giving a transform method. Transform the ball by giving the values here. Translate with the x and y coordinates. That's all. X pixels and y pixels and y pixels. That's all. Now the ball will be transformed. Now we have to call the animate function using the requestAnimationFrame, so that the loop will repeat again and again. Call the animate function, and we have to call the initially we have to call this whole function to start the actual animation. So call the animate function here. That's all. Now let's go to the browser and see how it actually moves. I reload. See, it is moving. It is moving at the logic we wrote. According to the logic we wrote, it is bouncing again and again, and it will at the final, after all the bouncing is complete, it will move flat, like rolling in the flat surfaces. That's all. I'm letting the animation run till it comes to the flat position. Let's see how long it goes. It is running and running, bouncing. You can see the bouncing is getting reduced by time. Now it is almost rolling now. See, now it is totally rolling. So that is how this actually happens. So yeah, I hope this animation is helpful for you, and I hope you use in some other different places as you wish. And yeah, that is it for today, and I will meet you guys in the next session. Please don't forget to like, subscribe and comment too. It will help me reach more more audience who really needs this video and who may find it helpful. And yeah, I will meet you guys in the next session with another animation. Thank you. Have a nice day.